Good morning. I'm Joseph Jayson P. Ocampo of the Isabela National High School, City of Ilagan, Isabela, and I would like to present my demo teaching in Bureau 21. Let's take a look at the picture of the shoppers. Can you determine which among the shopping cart is the heaviest? How? What are possible ways to determine which is the heaviest without actually weighing the carts in a weighing scale? Yes, John. The second card from the left, correct. What is your basis in saying card number 2? Any other observation from the rest? The picture shows that the second card from the left on your monitor with the check mark is the heaviest based on the mass of the content in the cart and would require greater amount of force to push. In our last session, you were able to learn about the effect of force to acceleration and also the effect of mass to acceleration. Based from the picture, what can you say about the picture in relation to mass, force, and acceleration? Yes, Jade, precisely. If the force applied to the cart is the same, the acceleration of the empty cart is greater than the acceleration of the loaded cart. Acceleration will increase when a large force is exerted. Therefore, we can say that acceleration is directly proportional to net force. This means that increasing the external force applied to an object will increase the object's acceleration. When force is doubled, acceleration is doubled. And we can also say that acceleration is inversely proportional to mass. This means that increasing the mass of an object will decrease the object's acceleration. When mass is doubled, acceleration is half. When mass is decreased 4 times, acceleration increases 4 times. For our today's session, we will be applying Newton's second law of motion by solving given problems. Take note that Newton's second law of motion, or the law of acceleration, can be summarized by the equation where a is the acceleration of the object in meters per second and F net is the net external force in newtons, and m is the mass of the object in kilograms. You may also refer to the formula triangle to solve for the quantity you are trying to work out. For instance, if force is the unknown quantity, cover the quantity, which will show you the formula needed for calculation. Get it? Now, let us first read the problems. For problem number 1, a 5 kilogram object is pushed along a frictionless floor with a force of 3 newtons. What is the acceleration of the object? For problem number 2, how much force is needed to cause a 2 kilogram object with an acceleration of 6 meters per second square? And for number 3, what is the mass of an object accelerated at 4 meters per second by a force of 20 newtons? And for the last problem, a cart with a mass of 8 kilograms is pulled along a horizontal rough surface with a force of 56 newtons. The floor offers a rolling friction of 16 newtons on the wheels of the cart. What is the acceleration of the cart? You are given 10 minutes to solve each problem, after which you have to show your answers with the complete solutions. You may now present your answers. Anyone? Okay, John, what is your answer? Correct. What about the next problem? Okay, congratulations for those who got the correct answers. As you can see, I have posted the correct answers on the monitor. Now, let's look at the picture and read each statement about force. Force is an action that can change motion. A force is what we call a push or pull, or any action that has the ability to change an object's motion. Forces can be used to increase the speed of an object, decrease the speed of an object, or change the direction in which an object is moving. Now, we can say that according to Newton's second law, if the same force is applied to an object with a greater mass, the object accelerates at a slower rate because mass adds inertia. We can also relate Newton's second law of motion in terms of productivity. Let us read and analyze what is being said in the article. Newton's second law of productivity. Second law of motion. Force equals mass multiplied by acceleration. The vector sum of the forces of an object is equal to the mass of that object multiplied by the acceleration vector of the object. Example, force equals mass times acceleration. Let's break down the equation. Force equals mass times acceleration and how it can be applied to productivity. There is one important thing to note in this equation. The force, or F, is a vector. Vectors involve both magnitude, meaning how much work you are putting in, and direction, where that work is focused. In other words, if you want to get an object accelerating in a particular direction, then the size of the force you apply and the direction of that force will both make a difference. Guess what? It's the same story for getting things done in your life. If you want to be productive, it's not merely about how hard you work or the magnitude. It's also about where the work is applied or the direction. This is true of big life decisions and small daily decisions. For example, you could apply the same skill set in different directions and get very different results. Now, who would like to tell us their idea regarding the diagram, which is about the physics of productivity? Yes, Ashley. Correct. Any more ideas? Now, let's sum our lessons up. With activities 1 to 8, you are able to investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. In other words, you describe the motion of an object in terms of the factors causing change in motion. To help you generalize your lessons, I would like you to answer briefly the questions that follow as your homework to be presented on our next session. Let's read the following questions. For question number 1, in terms of motion, what can external force do to an object? For number 2, does external force affect the object's acceleration? And for number 3, how does the object's mass affect its acceleration? And for your reflection, I would like you to answer the following. For number 1, I learned that, and for number 2, I enjoyed most on, and number 3, I want to learn more on. Okay, that's all for today's session. Congratulations for actively participating in our discussion. Please answer the questions based from what you have learned from our lessons together with your reflections. Keep safe always and thank you. See you on our next session.